Okay, so this talk is fantastic neural nets and where to find them. So I'll go over the Wolfram neural net repository. Let me just make this a little bit bigger so everyone can see properly. Okay, so today you're going to learn about the Wolfram neural net repository. So I'll start by going over a little bit of the background for the neural net repository. So you will learn about general uses and features. Then you will get a guided tour where you'll find out how to navigate the Wolfram neural net repository. After that, you'll learn about the anatomy of a net model. So the metadata associated with the resource object, as well as the components of the net model. And then I'll go over some examples so you can learn how to actually use these net models. And then very briefly, I'll go over submitting your own so you can learn how to use the definition notebook. Okay, so a little bit of background for the neural net repository. So a little bit about why this resource was created. Often working with neural nets can be difficult or frustrating because there are many different frameworks and different places that you might have to go to actually find the models that you want. And then once you have a model, sometimes you have to train it yourself, and which involves getting the data set, the time and the resources involved in training. When you're constructing your own models, you often don't want to start from scratch. You want to start from something where you can use some of the layers already to kind of make what you were actually looking for. So the neural net, the Wolfram neural net repository makes this easy for you by having everything in one place. So it's very comprehensive. We have a large assortment of high quality net models, and they are updated regularly with new models. So when we see a new model to convert, we put it in there. All of the models come pre-trained, which saves you training time. And it also saves you the headache because sometimes training sets are not publicly available. So there would be no way for you to train your own model based on that data set. And the best part is that everything is available within the Wolfram language. So there's no need to import from other frameworks. You can just use our framework. The net models can be used as is. They're pre-trained and ready to go. You can, the layers can be added or removed if you want to construct a new model. We also have an untrained version of the net, which you can train with your own data if you'd like. And you can submit your own, either privately to use, for your own purposes, or you can submit it publicly if you'd like to share it with other people if you think it's useful. Okay, so now a guided tour of the Wolfram neural net repository. So if we go here. So this is the neural net repository. It's set up a lot like the data repository. There's a little bit of information about the repository itself, and then it's organized by task type. So we've got classification, we've got feature extractors, we have image processing nets, and we have regression nets. And then if you notice within each of these, there's a title and a little bit of information about what the net actually does. And then if you hover over the little images here, you can see which input domain this takes. So basically, this net model will take as an input image data, whereas, for example, these will take text as the input. We also have audio models coming and numeric models coming as well. So there's also different ways to search through this. So if you wanted to just search by input domain, you can do that. You can pull up all of the image models. And again, you can just see the title and the description here, and then you can go to the actual model. You can also browse by task type. We also have an option to just look at everything that we have in alphabetical order. So you can look through this and say you were looking for a ResNet model, you could go straight to R, and you get all the ResNet models that we have. We also have search available. So if you were looking for ResNet models, you could just type in ResNet, and then we could return all of the ResNet models we have that way. Also on this taskbar, you'll notice there's a contact us. So you can fill this out if you have suggestions, questions, concerns. If you have a great suggestion for a model that isn't up here, you can put that in. So there's a bunch of different things that you can request from us. And then let's go over just one of the shingle pages. And if you click up here, you go right back to the landing page. So let's go over one of these. So say one of these image processing ones. So you'll notice we have the title, the brief description of what it does. There's some more information about the details about how it was constructed, when it came out, a little bit of information about the size before you download it. We also have this nice feature, which is training set information. So you can get information about the training set that this was actually trained on. And if you click the link, you can go straight to where the data came from. And then these are all very similar to the data repository. You can download the example notebook, which is exactly what you see on the screen here, these examples. You can open it in the cloud. So these examples show you a little bit about how to use the resource, so how to retrieve the resource object, how to get the pre-trained net, and then some of the more of the guts of what these models actually do. So this model, for example, you feed it a satellite photo and it creates a map for you. Also on these shingle pages, we have information. We have the construction notebook. So if you click on this, you can download the construction notebook, which, just bring this, sorry. So you can see here, we have, oops, sorry, wrong notebook. There we go. So this is the construction notebook, which shows you not only how to use some of the pieces of this, but also shows you how it was actually constructed. So what the parts are for it. And then some of these construction notebooks will show you how it was trained. Others, the training was done separately. So we have that. Also on this shingle page, you can see we tell you the Wolfram language requirements. So this particular model works with 11.2 or above. It will not work with 11.1, so that's something you want to keep in mind. And then we just have a reference where we have some information about this is the paper about the model, this is where to get the model itself, and then this is the rights associated with it. Okay, so all of this information is also available, through the Wolfram language. So if we move on to the next slide. So you can access the metadata of the resource object right in the Wolfram language. So if you evaluate this, you'll get this little box that has a little bit of information. If you hit the plus sign, you actually get a little bit more information. And if you want even more information, you can do, if you do resource object and then properties, you get all the properties that are associated with this. I won't go over all of them. I'll just show you a couple just to show you what's involved with getting these. So let's say we wanted to see when this is last updated. We would put in the latest update and we'd see it was updated in February of 2017. If you wanted to see which version of the Wolfram language you would need to use this resource, I mean, obviously it's in the title for this one, but in case it wasn't, you can see you need 11.1 to use this one. You can even, like I showed you, there's a way to open the example notebook, to view the example notebook from the website, and also to open it and download it from there. But there's also a way to get it straight from the language if you just do this. And of course, it's popping up on a different window. Sorry about that. So you can see a separate notebook will open, and you can just you can use it just like you would any other notebook, and it's the exact same information that's available on the website. And then each net model has a set list of components. So if you do resource object and then content elements, you'll see there's a construction notebook, evaluation net, uninitialized evaluation net, and then construction notebook expression. You can kind of just ignore the construction notebook expression. That's mostly for internal purposes that we have that there. And so the evaluation net is actually just the pre-trained net. So if you can do resource data and type in the model name, or you can do net model for specifically for the neural net repository, both work. So if we do this, we'll see we get our trained net model. You can see all of the different types of layers that are in it and the size of those layers. Each net model kind of has a different graphic for these. So some of them you can see the layers, some of them you can see a graph. It really depends on which one. And then you can also get the untrained network. So if you want that one, you would just do, inside the brackets, you do uninitialized evaluation net, and you can see it says uninitialized right on it. And the other things that would tip you off to that are these layers are red. So you can tell that this is an untrained model. So this you could train with whatever data that you wanted, and it just has the architecture of the net model. And then you can also get the construction notebook. I showed you how to get it straight from the website, but you can also get it from within the language. So if you do this, another notebook will open, and it has basically the same information. And like we just went over, this has information about how to get the construction notebook, the uninitialized evaluation net, and the evaluation net, and then information about how the model was actually constructed. Okay, so next I'll go over some examples of actually how to use these. So we'll start with an image from Star Wars, and we'll go just with this image for all of these. We have several models that are for general purpose object classification, including Wolfram Image Identify for Wolfram Language 11.1. We also have ImageNet models, Inception V1, V3, VGG, ResNet. So we have a bunch of those. So we'll just get the net model here, and you can see the net chain. And then we're just going to feed in this image to the net model and see what it thinks is the main object in the image. So we get Chewbacca, so it's been well trained. The top 5 guesses here. So it's pretty sure that it was Chewbacca, but it also could be some other kind of ape or hair slide. I'm not quite sure what that is. We also have object sub-itizing model, where basically it'll count the number of prominent items in an image. So again, you can get the net model here. So it's Inception V1 trained on extended salient object sub-itizing data. So if we feed this image into this model, it correctly gives us 2. We can also see all of the probabilities. So it only goes up to an interval of 4 to infinity, but it's pretty sure that there are 2 objects in that image. We also have a scene recognition model called Inception V1 trained on Places 365 data. And this will tell you the scene in the image. So if we feed it this image, it tells us this is a beauty salon. So that's not completely accurate all the time. If we get the top 10 guesses, we can see it wasn't really that confident about beauty salon, but it was the most confident about that. We also get some, silly ones like science museum or music studio or natural history museum. So, sometimes you can get some pretty funny results out of these, depending on what you feed it. We also have a geolocation model, which is pretty cool. So it's ResNet 101 trained on YFCC 100 million geotag data. So if we get that, so basically we can determine the geolocation of a photograph. So if we give it this photograph, it'll give us latitude and longitude coordinates of where it thinks this photograph was actually taken. And if we plot that position on a map, it comes up with New York City, which is as good a guess as any for something that happened in space. We can also obtain the top 50 guesses. So these are all the geo positions that it's guessing that we have. And then if we plot these on a world map with the, so the size of the bubble will indicate how sure it is of where this is. So it's pretty sure that it's either in New York City or somewhere it looks like Paris. But there's also these other guesses that this is where it could be. And then if we move on to image processing examples, you can see we've got a colorization net. So basically, if you have a black and white photo, we can run it through the ColorNet image colorization trained on ImageNet competition data. You can see this one is actually net graphs. You can see it's a little bit different than the last one, but you can see how all the pieces kind of fit together here. So basically we have a black and white version of this photo. If we feed it into here, we'll get the A and B channels of the LAB color space. We can find out what the dimensions of that is. And then we would need to write an evaluation function that would merge the A and B channels with the luminescence of the grayscale input. And then we can evaluate this photo on the evaluation function and see what happens, and hopefully it will colorize it. It does. You can tell it's not exactly the way that the original looked. If we, well, we can't scroll back that far, but you know, it looks more like a sepia photo, but it's definitely been colorized. We also have depth map regression models. So there's, I believe, 3 of them in here. We'll just do one. So the single image depth perception net trained on depth in the wild. So if we evaluate that, we can get the depth map of the image. There we go. And then we can visualize this. And so you can kind of see, I mean, it's not perfect, but you can kind of see, you know, the depth of Chewbacca's face, the sort of gun here, and then Harrison Ford's face. You can also do 3D visualizations on this. So this is a little bit cooler. So you can see much better the sort of 3D quality of that. And this one even is slightly better because it looks more like the photograph. So if you kind of turn this around, you can see that it's sort of a 3D photo now. We also have a style transfer network, which you may or may not have seen. So this is A to N style trained on MS Coco and Painter by Numbers data. So basically what this net does is it takes the content it takes the content of one image and restyles it in the style of another image. So if we use this as our content image and then a famous painting as our style image, we can restyle the photo. There we go. So now it kind of has this abstract quality to it. We also have a built-in function called image restyle, which uses this net model as the part of the back end, but it kind of resizes things so that you'll have something that is more in aspect ratio. So you notice like this kind of got squished, and this one is more of the correct size and comes out a little bit differently, but you can see, you know, it's about the same kind of abstractness. And then we have some facial analysis models as well. So basically all of these models will only work on facial crops. If you tried to run them on an image of this size, the results often come out incorrectly. So what you have to do first is, so we're going to use find faces in order to crop these images so that we can just run these images through these different models. So we have an age estimation model, age estimation VGG16 trained on IMDb wiki data. And let's see how old it thinks these faces are. Okay, so it comes out incorrectly for both of them. But we can see what the top 10 guesses are. So again, you know, it doesn't have a super high probability for either of these, that 13 is the correct answer, but that's the highest one we've got. We can see the entire range of the probability distribution. I believe that red is Chewbacca and blue is Han Solo. So you can see, especially for Han Solo, it's sort of a bimodal graph. So really it should be saying somewhere around here, because that's how old Harrison Ford actually was when he shot this film. But clearly, you know, sometimes you get slightly askew results. There's also a gender prediction net based on the same, it's trained on the same data set. So you can guess the gender of these faces. So it correctly guesses that both are male, or at least I assume Chewbacca is male. It's not quite as sure about Chewbacca as Harrison Ford, but that makes sense because this was trained on human faces, not Wookiee faces. We also have a couple facial key points nets, but we're going to go over just one of them. So this one is the vanilla CNN for facial landmark regression. So if we get the net and then run these faces through, these are the key points. So it gives you eyes, nose, and mouth corners. We can visualize these predictions by setting different colors for the different key points. And you can see it's fairly accurate. It's got both eyes, the nose, and the mouth corners for both faces. And then we also have a 3D facial model. So you can essentially make a 3D model of a face from a 2D image. It's unguided volumetric regression net for 3D face reconstruction. So if we run this image through there, we can see the dimensions of the volume, and then we can visualize the model. So this is pretty cool. We can get kind of this is sort of a 3D rendering of what Harrison Ford's face looks like. It's actually kind of neat that it looks like it's frozen in carbonite. And then this is just another version of that. So you can see we can get just the face model. Okay, so that concludes all of the examples that I'm going to show. We also, just like the data repository, we have a way of submitting your own neural net resource, which I won't spend too much time on because it's very much like for the data repository. You'd fill in all of your information here. You would put information about the training sets that you're using. You only need to put in your evaluation net here. We will, from this notebook, we'll get the examples, we'll get the construction notebook, as long as you fill in these fields, and we will get the untrained network from the trained network. And just like a data resource, you would create a resource object here. You can deploy it locally. You can deploy it to your own cloud, which is often a good way to start, just to see what you're going to come out with before you actually submit it to be publicly displayed. Or, I mean, if that's all you wanted, if you just wanted a resource that you can have constant access to, you can publicly deploy it to, or privately or publicly deploy it to your own cloud. And then if you get a publisher ID and you would like to submit a resource, you can do that through this resource notebook. Right now, this definition notebook is not available on the website, but it will be shortly. In the meantime, if you would like to submit something, if you're just dying to submit something, you can do so. You would just need to contact us via the Contact Us button, and we should be able to help you with to walk you through how to actually do that.